In this video, we will go through how to make schematic symbols and how to create their associated footprints. So in this case, what we have to do is we have to first create in Altium Designer a new project. So File, New, Project, PCB project. And currently we have no documents here. So the first thing we do, let's save this project so we have it under a certain name. I will create a new folder for it. And I will call the project Homework 1. Next, I'm going to add a library because the components that we want to build will be part of a library. So we go to Add New Project, Schematic Library. And it created the schematic library. It's called Schlib1. Let's save this too so we can actually rename it. In this case, let's just call it parts. There is a lot of different ways of what you can do with this schematic library or how to name them. For example, you can have multiple different libraries for the different vendors. In this case, since this is such a small project, we just will have one library itself. Next, we have to actually design our symbols that will be placed later on onto the schematic in this library. Altium has a really neat way of how to accelerate this, especially to get all the different part informations. So if you remember from last time, what we wanted to do is we wanted to create the MSP430 G2553. So let's copy this particular part number. And what we can do is we can use the supplier search. If you don't have it in your direct view, you can click on Systems, Supplier Search, and this window will pop up. And in here we can paste the part number, we can search, and it will search through a lot of different parts of different suppliers. And as you can see, there is a lot of different results. So what we can do is we can narrow this down a little bit and actually choose the exact part number that we want. So in this case, we look at, let's go back to DigiKey. This is an embedded microcontroller, and the part that we want is the TSOP20. So let's pick this particular part number here. And we have fewer results now, and you can see the different vendors. So in this case, let's choose DigiKey. I right click it and I say import into parts library. So what just happened is that it created a new part in my part library. If I actually drag in the window that shows me the part library, we can see it's the MSP430 that has been created here. This is the old component, an empty component that we can actually delete. But this one here is now our new part. It just consists of the part number. But if we double click on it with the left button, we can see it filled automatically out all the different parameters that later on can help you to design your system. So the first thing we will do is, since this is a microcontroller and IC, we will set the default designator to U question mark. The question mark will later on be replaced with a number. We want the default comment to be visible, but what we don't want is the supplier part number. That's this number here. We don't want to see that one. Instead, what we actually want to see is the manufacturer part number, since that one is a lot more telling. So if we zoom out here, we can see that there really is nothing done yet. So the next thing is we have to design our actual schematic symbol. With an IC, what we start with is we right click, we place a rectangle. This represents the body of our microcontroller. We can grab this one here and drag it underneath or on top. And the next part is we have to design our pins. So in order to do that, we go back to our browser here. And what we will do is we will basically place the same pins with very similar names that we see over here. So I will grab this window in this case and have it on a secondary monitor that you don't see right now. And what we can do now is I press P for placing a part, and then I can either click line, rectangle, where are they? Pin, PP. It starts at 35, which is not exactly what we want. So let's set the first one, and as you can see, we get automatically the next one with an increment. I will stop that for now, double click on this pin and say this is pin number 1 with designator number 1. I will rename them later on. Now I press PP again for place a pin. We have 2, 3, 4, 5, 6, 7, 8, 9, and 10. And with space, I rotate the pin around. We get 11, 12, and so on. Until we are at pin 20. Now my package that I drew was not quite large enough, so we just mark them and we can move them around, make this package the size that we want. All right. I saved the library just to make sure that nothing gets lost in case something crashes, and next step would be actually name these pins slightly better so that the design later on in the schematic will be easier. As you noticed, I double click on this name here, and then there is a pin down here that says edit pins. This is a nicer way of how you can edit the different parameters of the different pins that are out here. The designators we will keep with 1 through 20 because this is basically the link that will be used later on to associate a certain pin on a schematic symbol to a pad in the footprint that we will create next. But the name is what we can go and change. So in this case, pin number 1, I will change to DVCC. Then here I say P10, P11, P12. Okay, now we could add a lot more descriptions to this, and we could set them to different types to have the different properties of these I/O lines, but this will be good enough for what we want to do, except the things that I will go and change is for P1.6 that this is UCB0SCL and UCB0SDA. This is the I2C that we will use later on, and I will go and mark the UART on P11 over here because I want to remember that these are UART signals. UCA0RXD and UCA0TXD. Now again, the footprint don't look too great anymore, so we will move them out so we can actually read the different signals, and that will be it. Let's save the first schematic symbol. Next, we had our button, so again let's grab the part number. We go into the supplier search, and we found it on DigiKey. We right click, import it into the library, and again we created a new part in here, as you can see, with a new component. That's a switch, and all we have right now is the symbol itself. So let's move this down here, and there's lots of different ways of how you could do this. You could now go and draw the different switches. What I will do is I will create 2 pins, 1, 2. I will say this is pin number 1, but I will actually not make them visible because they're not necessary, and I will actually shorten its length down to just 10, and I will make this pin number 2. Again, I don't want to see anything because they're not necessary for a switch. There's not only one way of to connect them, and make it shorter too. In between, we can go and draw our switch. With space, you can flip things around. And you can change the way of how a line is drawn. So right now it would do everything in right angles. If I do space, it flips it around, or we can do it also in different angles. So what I want to do is I want to make a switch here. Not the most prettiest switch, but I think we get the idea. Of course, we could do something else a little bit more elaborate. We could go and look at the actual symbol for a switch itself. Actually, let me do that. I didn't like this at all. So what I will do is I will draw a line in here, also in here. With G, I can actually change the grid itself so that I can get half grids. I like this symbol a lot better. What we now can do is we can change it from black to blue. Oh, didn't do it for everything. And here's our switch symbol. Next one would be an LED. Let's go and grab that LED. Supplier search. As you can see, Mouser and DigiKey offer it. You can choose any one of them. I choose the DigiKey one, so that I have the same vendor for all the parts. I import it. And now it's time to draw our LED. Similar as before, I draw 2 pins. Now, we still have other parts. And we have passives, programming interface, and I/O breakout. Quick one for the passives. I would make a part for each and every one of them that we will need, but we don't really know yet which ones we actually end up using. So I will wait with that and create them later on. The process is exactly the same thing. You build this, you find a part that you like, import it into your library, create the schematic footprint, and later on associate it to a PCB footprint, which we will do next for some of these parts.